Hello everyone, welcome to Technology for Noobs. Today we are going to talk about a very interesting library which is making its noise in the world of technology, and that's called Chroma. First of all, if you are not aware of ChromaDB, let me explain you. If you are in the world of LLMs or creating any Gen AI app, data science apps or any chatbot, you might encounter there is some concept called vector database, and with that vector database, if you have to store those vector database, you need to have some DB, and the default one which every example is using is the Chroma. So this Chroma is an open source DB, and it's very specific for storing your embeddings with the documents. So it's like a NoSQL environment where you don't have a structure, and there is a certain key and pair which how ChromaDB expects your data to be, and then it make it easier for you to do a similarity search for any given query to whatever documents you are storing to it. So it gives you an end-to-end solution by just not providing a DB but also providing a services along to it or different supporting APIs. So in short, what I mean is, if you are building any Gen AI app or you are doing any home project, you might don't want to break your head on how to store databases, how to store the embeddings because they are already huge enough, how to do things. They have already done it, everything for you. So with 3 to 4 lines you are up and ready and you are good to go. So it could be a good knowledge to have if you are a data scientist, if you are a programmer, being in the world of LLMs, right? So this Chroma, as I said in their diagram also they have showed that a user passes a query and then it goes to a retrieval model. Retrieval models is nothing but it has all the word embeddings. It tries to fetch the nearest word embeddings for a given query, documents based on a given query, and then it gives LLM model does a little refinement and it shows the output to the end user. Now in all this, if you see, a lot of things are happening in the backend, but what exactly you need to do is just use this library and most of the things are taken care of automatically. So let's have a look into the document. So their document is very neat, small, and can make you up and ready in half an hour, I believe. You might not know the nitty gritty or some technical challenges which comes, but that's where I come in picture. I will help you on learning those and get started quickly. So let's jump into the problem statement. Already I have a notebook where I am in a particular environment of mine, and if I see if I have the ChromaDB here or not. And as you can see, there is no Chroma installed. So I'm here. I need to be on my environment. If you are not aware of Python environment, how to handle or manage it, let me know. I will create a small quick new video of it. The older ones are still there, but yeah. So I'm right now in 3.11. The first quick learning I can share is be on Python 3.10 and above. Don't be on 3.9 because it doesn't support some ChromaDB's requirement like SQLite 3, which needs a 3.5 version of SQLite, and 3.9 doesn't support the 3.5 version. So we are installing the ChromaDB, so that's our first step. So the another advantage with the Chroma is it provides you two kinds of interface. One is like a module based, and another is with the same module you can launch a API REST service, and it behaves like a normal DB, like where you have a string and you just use that REST API to do all the get, post, update operations. So I installed ChromaDB, it's able to pull it. So this is the first line. Chroma, we have to create a client. Let's see if it is able to do it, and yes. So when I executed ChromaDB.client, it has created me a DB instance. So if I execute it, you see this is all it is, and if I execute all this, it gives me what are the things I have. If I do heartbeat, it gives me a check whether my instance is running or not. this is now DB running here without doing any command execution and whatnot. See here, just one click and done. Now what important it provides us is, okay, let's do some experiments. Okay, so I want to create a collection. Simple. So if you know the NoSQL world where there is no structure, you just call any table as a collection, right? And that collection would have a group of documents related to it. So I will be creating a collection called my collection, let's say, and now I have my collection created. And if I do get, right now it's empty, but as you can see here, it provides me what are the things available in my DB. So if you would have provided any document to it, those would be in this particular key. This is a JSON response. And embeddings, if you would have provided embeddings, then it would have saved it. Okay, let me show you how it's done. So if I have to add any document in it, so a simple example is collection.add documents. This is document about pineapple, this is document about oranges, and I'm passing, okay, these are the IDs. And I will remind you, I have not passed any parameter here, any configuration while creating a client. I'm just doing out of the box. And I created a collection, I did a get operation and I checked. Now this command collection.add adds documents to it. So I can add multiple documents at one go by just passing a list of strings in documents, and then it will be there. And if I pass IDs, then it will store this as a IDs. So let's execute. And once executed, and if I do collection.get, and now you can see I have IDs, I have documents, and this is document blah 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 blah, right? Now there is something interesting I wanted to show you. When I do collection.get again, but this time I would pass include, and I have to say documents, just the same key here, right? This is the same thing I'm asking. Okay, and you see something interesting. See, when I did earlier, if you see collection.get, it said embeddings is equal to none, metadata none, and documents blah blah. But if I do it here and I ask very specifically, okay, provide me documents and embeddings, I see embeddings, but can you tell me where exactly embeddings were executed earlier? Nowhere. So now what advantage you get with the ChromaDB is this one, where there is a default embedding already and you can provide some configuration to have your own choice of embedding, and it automatically does all the things for you. Meaning what? When I pass this particular string, it actually calculated the embeddings and saved it without even asking you. That's the power of it. And if you have to do on your own, just imagine you would have the text, then you have to calculate the embeddings, store it in a required format, and then save it. And even while saving it, it might end up asking you why you are sending me 50,000 shape, 50,000 comma 1 shape of embeddings, right? So right now, or numerical values. If you see this embeddings, this is how it is. But this is a list of lists. But yeah, you got my point. Right? So now we have already covered one important thing. So as I said, it's like a NoSQL. You can do all the operations which are available. For now, I just showed you collection.get, and let's do some more interesting. So as I said, ChromaDB also helps you on doing a query search, meaning you don't really need to pass the entire value. If you just pass one keyword, it would find you a relevant document and it will give you the most nearest documents which you have passed into the DB by checking it by the nearest neighbors of their embeddings, right? So let's have a look at it. So how to do it is simple like this. Now if I have to do a query search, right? So this is an example code for that. results collection dot query text. So this is how you have to pass it, and then you would search for it, right? So this is how you search, and you say it, okay, give me top 10, top 2, top 10, top 100, up to you. And in this DB right now we have only entered 2, right? So let's just, and here if you see the output of the query is, it's saying, it's giving me the distance metrics also, how nearest those are with the given query, and it is providing me, okay, these are the documents which are in there. So I will just give one. So these are the documents which are nearest to it, and these are the only 2 documents which we added. Now let's do something else. If I say, okay, query text, and instead of all this I say apple, and the output which I get is both, because the pineapple and oranges are fruits, and the word embeddings are able to identify, okay, this is what they want. But now let's say search for shoes, and actually because we have only 2 records, it's just giving me the any 2 because these are coming. The another important, we will come back to this again in the next example, but there are more such search operations which you can do. I have another example just to look at it in another way. So right now, when in my previous example I was doing collection.query and I was asking, okay, give me a query text and search this query text in my DB and give me the nearest neighbors. So this is one way. But if I want to ask, okay, just tell me where this particular string exists. So for that there is another parameter which you need to pass, where document, and with this particular way of asking it, this is kind of an operator now, ampersand and contains or dollar contains, and then just simply ask, is there any apple in it? And if I do this collection.query what's wrong, okay, search for shoes, which is not there, but gives me the nearest neighbor for it. But what I'm saying is, whatever response you give me, just check if there is an apple word in it, right? This is what it means, where documents contain apple. And if I do a search, where is the output? And you see, now it has filtered it and it has given me only the first, only one response which has apple in it. So now I believe you have got the idea. See what it does, it helps you on creating a DB which does the embedding for you automatically, no need to break your head. You create a collection like you do in any NoSQL database, and then you start querying it. So there are ways of doing it, either you collect all and then you add your data in it, and then collection.get include document embeddings, and then you have collection.query query text, right? Simple, with the query text and number of results you want with the nearest neighbor in logic. Then you also have a conditional statement where you can say, okay, not just give me the top nearest neighbor, I mean top relevant documents, but also filter my output if it has an apple word on it or not. So very simple. So this was the quick start. Okay, there are some more technicalities which are missing here, so I will just talk to you here, which says, okay, you can do filter, you can do change any mechanism on how it's been calculated, that goes as a metadata while creating the collection, and blah blah blah, right? And you can also have any number of filters, the way to call it, or there is a using logical operator, you can have an AND operator on your metadata, like we had a where clause in our value, right? Similarly, we have all these functionalities which are available, and these are very standard conditional clauses or filtering logical operators which we use in NoSQL world as well. But let's do some more research and let's know more technical about this ChromaDB. So I will create another one. Okay, don't care about the name. So I have my ChromaDB. Now I have my client, right? So how many different types of clients I can have? So I have a Chroma client which has this client. Now it provides us a very vast, I mean it also provides us a relevant settings or configuration which we want to do. Like I want to persist this data. I don't want it to just be on my notebook. Right? Very easy requirement. So how to do it? So for that there is a particular keyword which we need to import. So the very first thing which comes to us is I do not see any DB stuff happening here anywhere, right? So let's talk about it now. So now here my first requirement is, okay, can I save it? Can I reuse it? And the answer is yes. And to do that we need to do something like this, and let me execute it once. It's Python, let's say, and if I execute it, yeah, it's able to execute it, but now I need to do some parameters. To do that I have to do a different setting. So ChromaDB dot, it's called persistent client, and within it I can pass, I have path as one of the arguments again. So once I do this and I execute this, and now you see I have a file created here which is now persisting it, right? So when I save it and I want to rework it, so next time I need to do is just execute the same command and it will search for that particular file and have our data there. Simple. Now if I have created this, now I would be creating a collection which says my collection, and if I do get, I have no data as of now, but if I do a add operation, now it has it. Now you see here, now a DB is created, a collection is created, now data are securely saved, and then if I do get again, I am able to find my all the information, blah blah, etc etc. All the same operations still holds true. Now let's redo it again, just to so my all the information is lost. I reinitiated it, I have it, I check hard, it's working. Now if I do get operation, but I do not have my collection as of now. So now if I have to do collection, I need my collection created, and it says the collection already exists. So for that what you can do is, there is a function called get or create collection, right? And once you execute it, it looks for it and sees if that exists. Yeah, it exists. Then just a get operation. You don't need to worry about it. Now once I do this exercise again, I'm able to retrieve my code again, I mean documents again. So this is very interesting. Now somebody would think next level. Okay, I'm able to persist. Okay, I know how to do a get operation, I know how to add documents. These are the most important thing. And I'm also able to do a get query, right? Simple. Now, so the embeddings which are being used to do all this experiment are the default embeddings, right? And what if I want to have my own custom embedding which I want to use here? So let's try to do that. So one important hint is, the embeddings need to be defined here. The embeddings are needed to be defined while creating the collection. So meaning what? So for each collection you can have a different set of embeddings which can be used to calculate the embeddings for a given string. So for that we will stick here only. So this is our collection. We have already created one, so we don't need to worry about it. we will create a new collection. And our task is we need to have our own separate embedding to work on. So for that, Chroma has its utils module, and from there we can have our embedding functions. So once I execute it, and if I check embedding functions dot, you see we have all sort of examples of function from where we can have our embeddings. So now my go-to library is the Hugging Face. I don't prefer much of the OpenAI. So now I have here. Now how to know if okay, just I can do help, and it says the default one says embedding functions, embedding blah blah. This is my default one, which is fine. This class is used to get embeddings for a list of text using the Hugging Face API, right? So what this will do is it will have this particular model in our system, and we would be good to go. So let's just simply say embedding functions, and we save it. Missing one position requirement that says okay, pass me the API. Let me check. So if I use this, then I need to pass an API and blah blah. But let's check, there is another function which I remember. So we have Amazon, Google instructor. So all those they support, and then the sentence transformer embedding. And what I need to do here is, if I have to pass a model name, so I have got a small model name with me, which is all mini LM L6V2, and just pass this model. So we'll know from where it will fetch it. Okay, just a minute. Let's find out what this function has. So what it says, embedding function, sentence transformer embedding. So this is the default one here. Such classes are primarily used with static type checkers that recognize structural subtyping. For example, whether to normalize return or not, which is good. So we need a model name if we want to specify which device to be used, and whether we need to normalize the embeddings or not. So for now we don't care about it, but let's so model name is how it is supposed to be. So this is the model name. Model name has to be passed here, and I execute it. So please install it with pip install. Okay, perfect. So this I think is coming from Hugging Face only, but yeah, let's install it. Okay, installed. So I need to, and that's how we would know whether our persistence thing were worked or not. So I did this, so it was able to fetch it. Chroma utils, embeddings, and then I have my embeddings here. So now it will download this particular model, and then it will have it ready for me. So I do not need all this now, which is fine. Now while creating another collection, let's call it collection 2, and it says my embeddings, right? So once it is in our system, next time it doesn't need that much of time, so that's okay. So this is executed here. Now we will do this. In the collection, I must have embedding functions is equal to embf, and if I execute this, embedding functions are not okay. The mistake was this. So now I have my collection 2. In my collection 2, if I add my documents, and if I do collection.get, include blah blah, so it's now working. If I do collection.query, it is working, and everything is as is, right? So simple. Now this is all I would want to share right now. You can go ahead again, have a watch at it, and just be cautious about the where filters wherever you are applying. So as you can see, collection.get, if I want to just say okay, just return me documents, it will return the documents. And if you want to do a query based on the embeddings also, that's also fine, there's no problem. The another thing which you need to focus is this metadata fields. So metadata field is nothing but I will show you. So here I created a collection, right? I created a document here. I mean this collection, right? Let's do it again. This is what we want to learn about the metadata. See, I am going to create a collection 3. Get or create a collection, and collection 3 is about metadata. Okay, my collection 3. So I now got my collection, and here I have collection.add. Where is it? Here is the collection dot. I have my collection 3.add, and I have my documents, I have my IDs, and now next would be I would have my metadata. So let's say I had these 2 documents. Now I want to add some metadata. So I have metadatas, and then these are the 2 metadata corresponding to each document. So whether it's from chapter 3, whether it's from chapter 3 verse 5, blah blah, this is just an example. And if I do execute, now I have it, collection 3, and if I do .get, I will get my 2 options, and I would have my metadata as well. Now let's say if I have to do a query, right? So this is my query. I want to do this as a query, and now let's say I want to say okay, in the metadata, I need to add a filter, where filter, right? To do that, if you remember earlier, we had a particular way of filtering our documents. So as I said, where documents, where we will have contain and whether it contains apple or not. But for the metadata, we were here. For metadata, it would be within where condition, just like in a normal SQL, right, where you have a where condition. So where, now what condition you want to ask for, right? So where, let's say chapter, no, let's say verse, where verse is equal to 16, okay, and this is in collection 3, results 2, and I executed and no response. Why? Okay, my query would be, let's say, just about apple. Now it is giving me 3, so it was in a string, that's why it didn't give it me in the first. So the first document came here as a response. Perfect. Now somebody would ask me, okay, saying what if I have multiple conditions, right, in simple word. So there is a format for it. So let's say you have a OR operator, you have AND operator, and all those. Just as you can see here, filtering. So we have all these operators, and results collection.3. Now this is how I have to pass the where clause, right? So I will just copy all this and I will paste it here, where, or and all this up. So our first where is verse metadata field, and my condition would be equal to in a inverted comma, and this is how it would be, and then my value should be 5, let's say. Good. And then my another is, let's say, chapter, and we are seeing or, right? So this is important, and let's just copy this, equal to, and let's say 3 and 16. No, chapter verse 5, chapter 3, and if I execute this, I will get both of my response, because chapter 5 is one of the condition, and chapter 3 is one of the condition, and verse 5 is one of the condition, and chapter 3 would get both by default. So just an example. So this is some. Now let's do now this was just to explain things, right? It takes time. But now let me do a quick POC. Okay, I will create a Streamlit app where I want to do a quick query based on the embeddings, right? So for that, let's create a new file which says app.py, and for this we need Streamlit. Let me just check pip install Streamlit. Let it do that. By that time we need a sample data. Let me fetch. So I found a database, sample data. Let's quickly go through it. So this is my app. Let's create another copy. This is for our experiment. Sorry for having a clumsy notebook, but yeah, I could not spend much time on organizing it all, but I believe this would do the job for now. So I want to fetch some data set, some text. I want to just show you how much easy it is to just create a POC using a ChromaDB for using a word embeddings and doing a search based on a nearest neighbor. So this will fetch me the data. Let's see first. Okay, it's loaded. News group find, and I have all the news group train. Okay, let's just look into the data. So this is my data, and let's do 10. So this is almost 11,000. We don't care about the 11,000. Let's this one be around 1,000. Okay. Now I have my first 1,000 documents. So documents is equal to length. Let's just create document length. Where is it? This one. And if I look into the first one, so this is all about where's my thing, subject, what car is this, what blah blah. It is too much of information. Good. So now what I want to do is I want to create a DB, and okay, I came up with the use case as well. So I have all the emails which I have got. This is the data we have, and I want to make a quick search. Okay, I want to do, if anything has been talked about a particular things, get me those documents only. So this is now my problem statement. So I have my DB here which is being persisted, which is great, and once my DB is here, I know the path. I can check the heartbeat. Yeah, it is running. Now I will create a collection, but I do not want all these collections. I'm specifically looking for something which uses my particular embeddings. So this is the embedding which I'm interested on, and here I will call it newspaper email collections. Okay. So this is our email, and I create a DB of it. And if I do a collection2.get, it fetches nothing. Now I want to add this document. So here, what I am not really interested on IDs. I am not really interested on let's say metadata. I am simply interested on having my documents there. So let's document slash, and voila, we are able to do it. Now let's simply do a get again and check. Yes, we have it. We have embeddings. Embeddings are there. Let's do include embeddings, comma, documents, and you see I have my embeddings, I have my document. So easy. So this is good. Now I don't need this. I know it. Now I would just run for I in range length of documents len. I want to execute this. Document I would give me that, and str of I will add the value. Should we try? Yeah. So it will update all the 1000 data points to my DB. How many we had selected? 1000, right? I should have added TQDM to get the status of it. But yeah, no problem. And it's executed. So it took around 44 seconds to calculate the embeddings and create a DB out of it. And now if I do collection2.get, and it is giving me a response, and if I see the IDs, it has all the information. Now we get it at least. Okay, so now the work is to create okay, let's do some experiments here only. What experiments we would be interested on? So we have our collection, we have our get. Let's do some query. Okay, collection.query and the number of results we are interested on. So I have collection2.query, and I even don't know what this data has, but let's say car. Query text has car, and I'm interested on top 10 results. Print, and the results are there with the okay. So I have import pandas as pd dot data frame, and now I have my results, and I know the documents. Kernel is dead. But that's not a problem. Let's clear output. We are not worried about all this, so we don't really need all this. We just really need to see if my DB still exists. Perfect. And embedding functions, perfect. And to recreate that particular collection, we should not change the settings. Okay, that is another important thing. So I have my collection, I have my this blah blah. I don't really need all this, and I just need this. Okay, perfect. I have pandas SPD, and here if I, let's say, do this, it's a car. See here, it's a car, safety, important, blah blah, all good. Now this is what we will be creating, a Streamlit app. Good. Streamlit app is here. Okay, Streamlit, run app.py. Which is fine. No module name stream. Oh, sorry. Perfect. So now I am able to do that. I will just do a quick Streamlit import text. Streamlit documentation, perfect. And I have st.text import. What things it needs? Where is an example? Here is an example. st title, perfect. So this is now my text. st dot title, my quick search app. Title, movie title, no, we want what you find me the email, and this would be my text. And st.write title, okay, what you looked, what you searched. So this is what it is. Find me the email, which has what you searched, life of brain, which is perfect. Now we need to have our logical code, which we have here. So what we need is first ChromaDB. Once we have it, I have my ChromaDB, then I have my heartbeat, I don't care. Then we have embeddings, all the things has to be there. Then I have my embedding function. Then I have collection, this is really important. And then I have my query. I got my query, print blah blah, st.write results. Save. So this has to be replaced by title, which we are looking for. And we are good. Do a rerun. I am looking for. Okay, it's running. So we got life of brain, and then there is a response for it, but we need to organize it. Okay, to organize it, we need to do some work. Experiment. I have my results. So in results, so this is our result, which has documents, which has distance, right? And documents, and we have nothing much. We don't really need the embeddings. So in results, I can have distances. Perfect. This I want pd.data frame. There is some problem here. My kernel is again crashed. I'm interested on this, or I can simply do it here. I have my results. I have this results documents. Import pandas std pd.data frame recap pd.data frame and this becomes my data, and I pass it here. Let's check if it So everything is clubbed here only. What we want is these are our results, and it's up to us how we want to do it, but somebody has to manually look into it and check if whatever results we are getting is enough or not. But see, we are up and running. We don't even really need to care about how to take care of the embeddings, how to calculate the distance. Everything is already done. So this is a quick experiment which I wanted to do and show you guys. Guns. Let's search for guns. And there are something, the pill for deer, no hunting. See, it is able proper gun control. I'm just looking at it, and still we are able to find it. So consider the use includes self-defense. Perfect. Up and running in no time. Thanks for your time. If you like it, please hit the like button and do subscribe to my channel. It really helps. And thanks and welcome to the Technology for Noob again. Thank you very much. Have a great day. Bye bye.